Well, everything is complicated. Apologies for the late start. And also, it seems like YouTube just decided that the stream key would stop working. Anyway, that's all sorted. So, I have a bunch of stuff I was thinking of looking at today. The first one is this issue on async. And it's kind of an interesting one because I've already fixed this problem, but I haven't committed it I haven't released it yet. It's an interesting problem because it shows some of the tricky design decisions you have to make in an event loop. So let's, I feel like I'm playing snakes. Put that up there. Which window is this going to hit? There we go. Excellent. Just see where I got up to. It's a ton of stuff there actually. Okay, first let's have a look at a quick example. So we're just going to pull in the local implementation of async. Since it's inside the gem repo itself, we'll just use require relative. Okay, let's see, can I run this, does it work? I'm sleeping. 10 is kind of a long time to sleep for, but it's okay. And just for good measure, let's do that. So, one of the interesting things about async is asynchronous event-driven code is not tricky in and of itself. What I mean by that is callbacks, you know, the fundamental kind of thing that's going on in an event loop it's not really tricky. You're just basically saying, when this event occurs, call this function or do this lambda or something. What I think, one of the problems I wanted to solve with async was not just making concurrency or improving concurrency, but also the life cycle of concurrency. And what I mean by that is when I first came from Celluloid, so I used to help maintain Celluloid IO, which I think, there we go, unmaintained. For all intents and purposes, it's dead. And I think that's okay, because Celluloid had a lot of global state and a lot of interesting issues, tricky issues actually. One of the issues that bothered me the most, and we'll see if we can find it in the code. I think it's this one. Awesome. This isn't quite, it's not really a specific example of the global state problem, but I do like the fact that there's this giant warning here that says do not introduce additional global variables. This linking request, this was a way to connect actors together so that if one actor crashed or failed or something, the other actor would know about it. It's been a while since I used Celluloid, so I can't remember specifically what problem you used to solve, you was trying to solve using linking, but in the case of RubyDNS, which is where I used Celluloid for like the first time, I wanted to have a server actor which then spun up like a TCP server and a UDP server, and they were linked into the server itself, so that if you stopped the server, it would stop the TCP server and the UDP server actors as well. And in theory, like you could spawn up lots of them. Like if your server had multiple interfaces that it was listening on, or you know, then you would have multiple children actors, and so this was a way of linking them. And what I particularly liked about this implementation was this constant here linking timeout. So basically, firstly, celluloid exclusive is a global contention. Then it made this thing called linking request, and it would basically wait for linking timeout. Let's find out what linking timeout is. I think it's 5 seconds. Okay, must be somewhere else. You know what? I think I have celluloid on my system. Let's just go straight into the source code. So I'm just going to double check this is streaming. I sort of don't have faith in YouTube at the moment. Is it strange to watch your own stream? Somewhere else. Okay, I'm sure that's recursive enough. Excellent. Okay, right, so linking timeout. 5 seconds. So it would basically wait 5 seconds to try and do this this dance between two actors. And it was exclusive as well, so like while this was happening, nothing else in the system would work. You know, it's pretty crazy, really. So, for what it's worth, Celluloid was a pretty interesting system. It definitely pushed the boundaries of how people should express problems and concurrency and parallelism, but ultimately stuff like this just made me really concerned about using it. And I guess in general with actors, they were all global, like they all just sat in the global namespace. They weren't isolated, so you couldn't, cleaning up after them was really tricky. So if you had unit tests and you wanted to spin up a server for the duration of the unit test, and the end of the unit test it should go away, that was pretty tricky with Celluloid. It was not sort of by default. It was quite a lot of work to do that. So with async, the very first thing for me was that async should just be a block, and everything that is in the block stays in the block and nothing leaks out of the block. So what you notice is, because this is the top level block, this is actually what creates the reactor, and then it executes this task as a subtask and it sleeps for 2 seconds. We can have a quick look at like what that actually looks like. So I'm just going to get the parent task, and I'm going to do parent print. I think that should do what I want. So I run this and I get this hierarchy printed out, which is, that's the parent task and that's the child task. You can actually go one level up. We can ask the reactor to print itself out. So there's the reactor. There is the top level task, that one. And that one is the nested task. And if you don't believe me, we can even annotate them. Not particularly creative annotations. Right, so now parent and child show up in that hierarchy. So what was really important to me was that nothing escapes this, because I like predictable code. I like code that I can reason about. And so what's interesting is that even within this nested context, while it's not strictly the same behavior, in your own code, nothing should escape this either. And so what I mean by that is that you should have appropriate ensure blocks to make sure you tidy up anything that you're doing. So if you head a file, you should close it afterwards. And that will guarantee the behavior and consistency of your code. You're not leaking files, for example. Right, so how does stop play into all this? One of the really critical things in any system, especially with Ruby DNS, was as a server, you need a way to stop it gracefully. And by graceful, I mean not just exiting the process, I mean actually terminating it some way. So it was important to me early on to have this concept of stopping a task and having that behave in a predictable way. So what that means is you can go task.stop. And let's just capture that. Closing file because... So if there's an exception, it will show up there. So what's going to happen is we'll execute this. It's going to go to sleep. That's going to yield, and then this task will keep on executing. It's going to call task.stop, and that's going to basically come out of this sleep with an exception called a async stop exception. It's still going to run your ensure block, and then it's going to exit out and finish the whole program. Whoops, what have I done? There we go. I'm sleeping, but then I'm closing file because of async stop, and then the program finishes. Let's just get rid of that hierarchy. It's not really that helpful. So where this is really useful is if you decide to make a web server. Hopefully I can get this right. Without, I probably need to look at the documentation. So let's just spin up a web server. Actually, I need to use, not that one. So I'll just make a web server on localhost 9292. I think it's server.run, it might be server.start. Now, how do we provide some behavior to that? I might have to look up the documentation for that. I love how I say looking at the documentation, I just look at the source code. The ultimate source of documentation. Okay, cool. I can just use this one here. Okay, let me just bring up, let me just run it for 60 seconds. Okay, and let me see if that works. Okay, it almost worked. It crashed. Is that not? Oh, I think I just want changed it a little bit. Okay, great. Let's actually put some text in there. Okay, we'll start that up again. There we go, we can hit the web server. So I like the fact you can make your own web server in, I guess like about 20 lines of code. Let's just call it an even 20. So the nature of stopping this is non-trivial, simply because there are lots of ways you could define stopping. Like if this was a long-running request, you may want to finish that request before you terminate it, or maybe you don't care. Task.stop doesn't actually control that kind of graceful behavior, but you can access it through this mechanism. To show you why it gets more complicated, let's consider that in the request we get the path. Let's just have a look at what that comes through as, so I just don't stuff it up. What did it return an array of tasks? Okay, I don't know why it was an array. I should probably know these things. Right. So let's do our query again. Cool. So we get that as a slash at the start. So let's just solve that with a regular expression. I don't know why I'm doing that, but it seems logical. Maybe it's not. Right, so awesome. So whatever we put at the end there, we get as a keyword. So in here, let's instantiate the internet. Right, and then we're just gonna we're gonna query the internet. So this is quite a tricky one because it looks simple, but it's actually not that simple. We're instantiating the internet here, which is a connection cache. It has a connection pool, which it will reuse as efficiently as possible. It can connect using HTTP1, which may or may not be keep alive. HTTP2, which is the same but generally by default is keep alive. And also HTTP2, which multiplexes connections across a single stream, but also has its own set of limitations regarding how many connections you can funnel across. So that's all transparently handled by that. So when we do this, we could be reusing an existing HTTP2 connection. In fact, that's highly likely because it's Google and it's going over HTTPS. So when we have an HTTP2 connection, this will actually spawn multiple background tasks. So what it is, I will put a loop in here, and I will just print out the hierarchy. So it's gonna, every 10 seconds it's gonna print out what the task tree of this looks like. So we can see what's happening. It won't be beautiful, but it will at least give us some idea of what's going on. So we want to read the response body. To do that most efficiently, you want to read it in chunks. Actually, I've been tackling this issue. Maybe someone can help me understand it better, but on the JVM, it seems like you're limited to 2 GB strings, 2 GB mem maps, 2 GB chunks, 2 GB whatever. Like you can't allocate more than 2 GB of data, like sequential data in the JVM. Apparently, because they decided signed 32-bit integers was a great idea for the length field, which blows me away because when was the JVM made? Like they knew that 64-bit indexes was important, right? So I don't completely understand why they made that decision. And so any API, of course, even this is supported. If you go response.read, but if your response is bigger than 2 GB, I mean, firstly, it's a really terrible idea if the response is huge, just to try and buffer it all, because you'll use a whole bunch of memory, but it just, the whole way people do things in Ruby, like file dot, read lines, if that's big data, and we're talking like really big data, not what people typically call big data, that could just blow up in the JVM. You'd be fine on a 64-bit operating system. Actually, I guess it's more likely that would blow up because file.readlines at least should allocate separate strings. But it still surprises me that we're facing that problem. I'm not quite sure what the solution is with the JVM, unless you just build all your APIs to be streaming, like i.e., getting lists of chunks and assuming that you just keep on getting chunks until you get nil. I don't know. I don't know what the solution is. But async, I've built it around the idea of chunks. And so response.read actually just joins all the chunks together, it reads them all and joins them. It's, by default async, and async HTTP is working on a chunk level. So this will actually stream, HTTP2 uses data frames. You'll get 1 chunk per data frame. So it's basically as efficient as it possibly can be. And so what we're going to do with that, actually, to be completely honest, since we know the response is going to be short and I just went on a giant tirade about using chunks, I'm just going to go, I'm just going to do this. Actually, let me just double check it's going to do what I want. Okay. So that's kind of it's kind of really emphasizes my point. Like in Ruby, we're just kind of like used to writing code like response.read.scan for those things and count them. And yet it's much more tricky if I was going to try and like write this and have that scan behave, like work on chunks of data. Or maybe it's possible internally, but if you think about it, if that string is big, you have to match across the boundaries of chunks. It just would get super complicated. So yeah, again, like I don't know what the solution is. All I know is that it's not that simple. Right, so the great thing about this is that even though this could potentially take a long time, it won't block other requests because they're all working asynchronously. So we get the count, and then we're going to say Google found and you know what, I should use count, I should use size. Otherwise, we're just going to return a 404 error. I'm just going to do this to make it more obvious what's going on. Okay, let's see what happens. So first it should be printing out every 10 seconds. Let's just make it a little bit faster. Okay, great. So what you see here is there's a reactor, there is our task, and then there are two tasks, which one is bound to IPv6 and one is bound to IPv4. So there's actually two servers running. So let's try querying it and see what happens. Google found 65 instances of kittens. There should probably be a new line at the end that will make it a bit nicer. Okay, let's try that again. Then we'll have a look at the output of the reactor. So what you see here is now we've got the reactor, there's our task, the top level task, then there's the IPv6 server which we just talked to and sent a request to, and now what you notice is there's actually this child task which is connected to Google. That's completed because that task was a one-shot task, but there's actually this background task which is reading data, and that is actually maintaining the HTTP2 connection. It's sitting in there. So if you thought that it was just possible to kill this server, actually I probably should use the word stop to be consistent. If you thought it's possible to stop this server just by terminating like the top level tasks, you're wrong. If this code running in this area is the user code, you can't make any assumptions about the nature of this code, the lifetime of this code, anything that's going on here, it's completely arbitrary. But stop in async will correctly handle that. So when you fire stop, it will actually hit this background task, and it will tidy up the connection correctly. So let's have a quick look at that. It is sitting in here, I think. No, hold on. Yeah, this one. So this is the read in background, and this is where it makes the actual task. And it actually updates the streaming windows for data frames, and then it reads any outstanding frames. And then finally it has this ensure block, which will close the connection as quickly and as gracefully as possible. So let's show that that is possible to do. What I will do is I'll make that sleep 10. So we can do like a handful of queries, and then after 10 seconds the server will be terminated. So stop is a little bit tricky because the point is that you can always call stop and it should always do the right thing, which means whatever task you aim towards, it should stop. And actually, so we have this issue come up, and I've noticed this before and I didn't know why it was happening, is when you press Control-C, it would call stop, but you end up getting this double resume error, and my response was it needs further investigation. Can we reproduce it? I thought I fixed the problem. I thought it was trying to resume itself. Like someone was saying, basically like parent.stop. So they're inside the parent and then they're trying to stop it themselves, which obviously is, it should be okay. Like what this does now is it will just raise the stop exception right there, which is fine because it has the desired behavior. What became really tricky, however, was this specific situation, which is now fixed, so I don't know if it will actually fail anymore, but we can try running it anyway. Okay, cool. We got a failure. Now, I think if I use the local version, it should pass. Fingers crossed. Let me see. Was this the correct repo? I think that repo is a bit funny. Hold on. This one. Let me double check I'm using the correct code. Should be using this one. This has got the fix. The fix is that line there. Stop later. If you can't stop it now, stop it later. I also put this in a spec, so let me check. It can be stopped, it can stop nested tasks, it can kill direct charge and one of these is the right one. Okay, let's see if we can make this I think I don't want the loop. So that blows up. Maybe it doesn't matter that it's not exiting because it was stuck in a loop anyway. In theory, that should exit. Produce the dot stop. Hold on, that's also so I shouldn't be doing that. Is stop later actually working? Okay, so let me explain what the problem is basically, and then we'll look at the solution. Maybe it's not working as well as I thought it was, in which case I need to go back to the drawing board. So this is a condition, and the way that conditions work is they transfer control directly from when you call signal on a condition, it goes through all the fibers that are waiting and just directly calls resume. And the reason why that's a problem is that this code executes and it comes into the producer and it starts producing values. We call yield, which then means we come back out and execute this line here. This waits on the condition, and the condition is not ready yet. So basically it goes into the reactor. Actually, let's just double check that actually. Condition wait calls task.yield. So it goes back into the reactor. And then what happens is eventually this will come back on the next iteration of the run loop. And so we come here and we signal, and that directly resumes this fiber. And then what that does is it calls producer.stop. And what stop does is stop tries to resume this task, but we're already nested inside this task. So you can't resume a task that's already resumed, so you get a double resume error. So that's what happens. And it happens inside stop when stop tries to call resume, because the task was already resumed. So what I did was, after a bit of like umming and ahhing, I decided to rescue that error, and it annoys me that there's no easy way to detect that. And essentially we put the fiber back to how it was, but we insert into the reactor this stop later thing. Now, it looks like we need to debug why this is not working. So stop later takes a task, and when this is kind of a fake resumable, like it's a kind of a fake fiber in terms of how the reactor looks, but the reactor will just call resume on it, and that itself calls task.stop on the next iteration through the reactor. So I don't know why that's not triggering the whole thing to exit. It should just be sort of like a deck of cards that eventually folds out. But let's have a look if stop later is getting invoked or not. Use the new code. I guess let's have a look. So we're called from the reactor, and so then we should be stopping the task. Let's just annotate it so we can see which one we're talking about. This is definitely the subtask we're trying to stop. So in theory, when that subtask yields, it gets resumed by the reactor. Let's have a quick look at the run loop of the reactor, see if we can figure out what's going on. So when you call, actually there's two different ways that can get in there, but let's have a look. So it's calling subtask.yield, so it's calling task yield. That just goes directly to reactor.yield. Let's have a look at reactor. So it puts the current fiber into the ready list. I wonder if the ready list is always containing that fiber and it's getting hit first. Yeah, that looks okay. Okay, so does the stop later? So why isn't it stopping it? At this point, I'm just like so confused. I think half the time I'm debugging, I'm just confused. I don't know what, you know, if I wasn't confused, I have already solved the problem, so. So that should definitely be calling task.stop. So let's just try that. How is it enumerating them? Fiber.resume and fiber.alive. That's fine, it should be working. So right, okay, so we stopped, we called stop, and that, let's have a look at the code, that printed out producer yielding. So did it go around the loop one time? Stop should have raised an exception. Why was the exception clobbered? Okay, why don't we... Actually, I want to come out. Okay, great. So this should be on the way out. We should have an exception here. But we don't have an exception. We called yield, we were resumed. I think I know what might have happened. So actually this is actually, there's a PR I've made against Ruby that might relate to this, but I think that will fix the issue. Okay, great, problem solved. Okay, so let me try and explain what just happened. We made like one change to this function and it fixed the problem. Actually, that's a bug. So it's not just a problem with this particular issue that I'm trying to solve here, but this should have been this way since before as well. so it represents a unique bug in async, which will get fixed, which is good. What is task.yield? One of the important points in async is that tasks wrap around fibers, and tasks provide a little bit more semantic model. Task.yield, it calls fiber.yield, and it gets the result, and if the result is an exception, then it raises it, otherwise it returns it. And so what this means is, when you resume a fiber, if you want that fiber to blow up with an exception, then you call fiber.resume exception, and then when it comes back out here, it will blow up. Now, there is this convenient thing here, which is when you need to implement your own logic for fiber.yield, you can just provide a block and it will call yield and everything else is the same. So reactor.yield is essentially calling fiber.yield here, and that is not checking the result, like if it's an exception, which is logical because this is actually not inside the semantic. This is the semantic model of the reactor, not the task. But within the task, if you call task yield, it does make sense to correctly handle that exception. Now, it's funny because in my mind, this is actually kind of a shortcoming of the fiber interface, as well as the fact that you can't tell if you're already resumed, you have to catch the exception. I'm actually okay with that. Like, I don't really care because it's such a... when you're stopping a task, you expect some kind of performance overhead. And so I'm fine that it throws an exception, but exceptions are pretty expensive in terms of performance, so you wouldn't want that to be like the normal thing that you're doing all the time. Let's see if I can just find this bug report. So this was an interesting bug that was created 5 years ago, and I believe it was actually approved by Mats, although I'm not quite sure if he posted on this issue or not. It always, like, from a certain point of view, like, it always annoys me when there's issues that have been sitting around for 5 years and they make sense, but just because people are kind of not sure, not convinced. I don't know, like, it, from a certain point of view, like, it bothers me. I also completely understand why this was sitting around for 5 years. Obviously, you need to have people getting behind issues and saying, oh, this is important or whatever. But, you know, it's just fascinating how that whole thing plays out. So anyway, let's have a look at the example. Fiber equals fiber.new do counter equals 0, loop counter plus equals fiber yield counter, fiber resume, fiber.res stop iteration. Fair enough. So like the whole point is that you can basically call fiber.res with an exception. And it makes sense because in threads you can do the same thing as well. Although I'm not convinced it's a good idea to do that with threads. Okay, so we made a thread that's just sleeping forever. And is it thread.raise? Yeah, there is thread.raise. Okay, cool. So the thread was terminated with an exception, and the exception was boom. And if you call t.join, I think that raises the exception. But fibers didn't have that until this patch was merged in 2.7 by me, because I thought it actually makes a lot of sense, because otherwise everyone is just implementing their own version of this. And that's not pretty, and it's not efficient. if it can be done in C, it's way, this is a hot code path in some situations. So this was merged. Actually, I didn't see this comment, so I'm interested in what someone else said here. Shortly after I started to work on a library implementing algebraic effects, I stumbled upon a lack of 5 arrays. From the user point of view, it is important to signal improper use of effects with a meaningful stack trace so they can quickly detect what's wrong. It's possible to emulate arrays but with checks, but it's quite inefficient and seems redundant. Thank you all your folks for discussing work on the Homeland 2.0. Sure, clear example task is almost in. Okay, yeah, right. So, I actually have to write the news, so we could do that today before we finish off, because I guess that makes sense. But unfortunately, because async, my plan for async is at least for a while to keep on supporting 2.3, so this will stick around for quite a while. Sometimes I decide, the performance is worth it, so I can just go if fiber.respond to raise or something, then def self.yield some function else, some other function. But I don't really like having super tricky conditional methods. In my mind, I just wait until 3.0 is released and bump up the minimum version and re-implement it and change the interface as required. Right, so I want to release this, but and I was thinking of doing it today, but I just want to sleep on it a little bit longer because this is quite a tricky problem, and I don't want to release something that's semantically wrong, especially since this is changing async's kind of public behavior. It's fixing what currently doesn't work, so it's not like a regression in a sense. But I guess the whole idea of stopping tasks is non-trivial, and what this basically does is it says if I can't stop it now because it's stuck somewhere in the call chain, stop it later. And I think that is logical, but the only problem I have with that is that it then means that stopping the task is deferred until a point in time. Even though you call task.stop, you may not have stopped the task. And to me, that bothers me quite a bit because, like I said at the very start, the whole point of async is to look at managing the life cycle and having sane assumptions about that life cycle. So it really bothers me a lot that there is no simple solution to this. But I think at the end of the day, having a mechanism for stopping tasks that's robust is more important than maybe, or in fact, maybe there's no alternative. The alternative is to crash. So, I guess one way or another you're going to be stopping. But I prefer that the program keeps on running in a way that makes sense. So, actually, I'm kind of curious. Let's just have a look at fiber.raise, because I haven't even looked at it for a while. The implementation, I didn't even have to write, it just made some minor tweaks and merged what was already here. Let me call out the person who originally implemented it. Was it? I'm sorry, I have no idea how to pronounce his real name, but I guess his nickname is Nom. I don't know. So I just, thanks to him, he made the original patches, and I just basically merged them in. So yes, it's amazing how that was 5 years ago, and we just managed to get it in today. So let's try it out. RVM list, RVM is Ruby head, RB. Hold on. Okay, cool. So that works. And just so we can convince ourselves. Okay, 2.6.3. Right, so 2.6 doesn't have it. but in theory 2.7 does. So let's try it out. I will write the code and paste it in. Okay, that part seems to have worked. Right, so we called fiber.resume. It came in the top of the fiber. It came into the begin block. It printed out fiber.yield, and then it called fiber.yield, which came back to here. And then we're just going to call fiber.raise, boom, and we got boom, because we just printed it out and ignored it, which is fine. And I guess in effect, fiber.alive. It's no longer alive because after it printed it out, it exited off the end. So I have to write the news for this. So let's do that and then we'll wrap it up. Okay, where am I? Okay. Changes since the 2.6.0 release. I love how everyone just collaborates on this file. It's so awesome. It's so exciting to see stuff. Like, there's like thousands of changes which don't make it into this news file, but as a developer, it's just always exciting because people try and summarize like 1 month of work into a sentence. So every sentence is like super exciting. At least to me it is. So is there like a section for fiber? Yes, there is, but that one is just the C API. That's what I wrote previously. Yeah, 10 times improvement. That's pretty impressive. But we want the Ruby interface. I wonder if this is alphabetic. Language changes. I don't know what order this should be in. I just added at the end. Core classes updates. A, B, C, D, E, F. Okay, I think it goes in here. Also, I have no idea how this formatting works, so I just copy the previous entry. New method. Added fiber raise. Feature that. So like this one line is 5 years of work. Not quite 5 years of work. That behaves like fiber resume, but raises and exception. I'm over 80 characters. On the resumed fiber. That is perfect. Koichi will be so happy. Excellent. Fiber, new method. That looks okay to me. Very good. So that was pretty crazy debugging session, but that's what it is from time to time, especially when you have tricky issues. And I guess ultimately, like, you try and find, at least with async, like I'm trying to be really careful about the size of this code base and also the semantic complexity. What I mean by that is I just don't want to like make arbitrary decisions. Like every decision in here is really carefully considered, because in the past, like I've just seen things fall to pieces because the decisions weren't careful enough. And the problem is, if you have a crappy foundation, everyone building on top of it has crappy houses, and that's just the reality of the situation. So I'm trying to make async a super solid foundation for concurrency in Ruby, and it's pretty much based on just like maybe 10 years of experience. But there's still issues that come up just either due to the complexity of Ruby or specific issues within Ruby. It's really exciting, I guess, in that regard. But also sometimes very tricky. And, stuff like that, it bothers me slightly, but that's just the way it is. So. Anyway, I hope it's been as interesting for you as it has been for me, and hopefully we can push these changes in a release soon. I did want to do it today, but I'm just not completely confident in it yet. There may be some additional changes. I probably should spec up that behavior as well, make sure there's specs that cover it, so we don't have any regressions later on. Excellent. Well, it's quite late, so I will be heading off now. Thank you very much.